All right, hello and welcome. So today we're going to be looking at two examples of word problems um, involving systems of equations. So the math of how we're going to solve these formulas is going to be the same as what we've been doing in the past couple of videos. The only difference is that now we need to be able to read through the paragraph and figure out um, like what the equations are supposed to be based on the information. So if I'm looking at this first one right here, it tells me that Billy has ordered 200 flowers for Mother's Day. He orders carnations at $150 each, roses at $5.75 each, and daisies at $2.60 each. So we've got three different types of flowers. We know that those are probably going to end up being our variables. He also knows that we have 20 fewer roses than daisies, and the total order came to $589.50. So we have a lot of information here. The biggest challenge at first is going to be just figuring out which bits of this were important and which words we can kind of like gloss over, or like what is the most important bits just for writing the equations. So if you are struggling with that, start with this last sentence right here. So it says how many uh, of each type of flower was ordered. So that means that my X, Y, and Z are going to represent the types of flowers. So the first thing I'm going to do is just write down what my variables are. So I'm going to let X represent my carnations. Y can equal my roses. And Z can equal my daisies. So from here, I'm going to go back to the paragraph and look for any other important information that they've given me. And so what I should be looking for are things that tell me like total values and things that tell me like how many more or less of one thing we have than another. And so the first thing I notice is that they have the total cost of $589.50. That's right from right here. So that tells me that one of my equations should have something that totals up to 589.5. And so to figure out what my equation should look like, I'm going to go back to the paragraph and look for any dollar amounts that I see. So the first thing I notice is that the carnations are $1.50 each. So in my equation, I'll start with 1.5x. My roses are $5.75 each. So I should add 5.75y to my equation. And then finally, my daisies are $2.60 each. So I should add 2.6z to my equation. All right, so let's go back and see if we have any other important information. So I look at this second sentence right here, and it says they mostly ordered carnations, which doesn't help me a whole lot, but I know there's 20 fewer roses than daisies. So my clue that this is important is simply that it has a number there, and that it mentions my roses and my daisies. So I'm going to use this to write another equation. So if I have 20 fewer roses than daisies, then I'm going to write an equation that uses my y and my z. So if I have 20 fewer roses than daisies, that means I want to say that z minus 20 equals y. And so the last thing that I need to know is that the restaurant ordered 200 total flowers. So since my x's, y's, and z's just represent the number of flowers, if I have a total of 200, that means my three variables together should make 200 in total. So we now have our three equations and our three variables, which means we can set this up just like we did with the previous videos where we used the matrix to simplify our equations. Just remember that in order for the matrix to work, your x's, y's, and z's all have to line up before the equal sign. So if I look at the equations that I have written, the first equation with the money is fine because it goes x, y, z, and then a number. The middle equation does not work as written because the z is supposed to come before the equal sign. So what I'm going to do is subtract the z to get it on the other side. So what I should really have written there is y minus z equals negative 20. So let's move that up here. And then when I go to my third equation, it says x, y, z, and then 20. So that's lined up the way that we want it. So now what we can do, oops, not 20, 200. That's important. Okay. So let's go back and now put these into our matrix. And so here's our matrix. Notice for the top row, we just copied the numbers as is. The second equation, we were missing an x, so we left it as 0. But we had 1y, negative 1z, and a negative 20 on the end. And then on the bottom, we had 1x, 1y, 1z, and they totaled up to 200. So we'll go ahead and get Desmos to simplify for us, and we notice that 1x equals 80, 1y equals 50, and 1z equals 70. We can go ahead and go back to where we had our variables written down and just fill in the numbers that we now know. So we said we have 80 for x, 50 for y, and 70 for z. So we have 80 carnations, 50 roses, and 70 daisies. All right, let's look at one more of these. So just like last time, I want to find the most important bits of information first. So I'm going to drop down to the end where I actually see the question. So the important bits here is that we are asked how many of each type of ticket was sold. So the first thing I need to do is probably figure out how many different ticket types there are. So if I jump up to the sentence before this, I notice I've got matinee, student, and regular admissions. So when I set this up, I'm going to use X for my matinee, Y for my student tickets, and Z for my regular tickets. So the next thing I'm going to do is look for any total values that I see. So here I see that the total cost should be $64,600. So I'm going to take each of the dollar values I see and use those to write my first equation. So we should see 5x plus 6y plus 8.5z equals 64,600. The next total value that I see was in the first sentence, where it says a total of 8,500 movie tickets were sold. So I'm going to use that to write my second equation. So on my second row, I will put x plus y plus z equals 8,500. So I don't see any more totals in the paragraph, but I do see that I should have twice as many student tickets as matinee tickets. So I'm going to use that to write my third row. Twice as many student tickets as matinee tickets. My third equation is going to be y equals 2x. And just like before, we know that the x needs to come before the equal sign. So to get it over where I want it, I'm going to do a minus 2x on both sides. So my third row should read negative 2x plus y equals to 0. All right, so now I'm just going to take these three equations, put them into my matrix, and get my solution. And so as we can see, with this system of equations, our solution should be 1x equal to 900, 1y equal to 1800, and 1z equal to 5800. That's this as our final solution. That's all I have for this one. I will see you guys next.